In this video, we're going to take a look at the different energy sources that we have on Earth. Most of the energy that we use is converted into electrical energy and then back into some other form. And that's because electrical energy is easy for us to move around. We have developed a power grid that conducts electricity all over the country, and then we can easily convert it into other things. We can plug in a vacuum cleaner, we can turn on a light bulb, we can turn on a toaster, we can turn on electric motors. Any of those things that we rely on for electricity is just converting electrical energy into some other form of energy. But first we had to get electric energy. And this shows a coal burning power plant, but it doesn't matter if it's a coal burning power plant, a nuclear power plant, a hydro power plant, or a wind turbine. They're all doing the same thing. They're trying to turn a magnet through some wires in order to generate an electric current. Now in a coal-fired power plant, we take coal, smash it up into dust particles, inject it into this firebox, light it on fire, which causes water to change from the liquid state into the vapor state, right? So we add enough energy to water, the particles separate, and instead of liquid water, we have gaseous water. And it comes in here and it turns this turbine, which is basically a propeller, catches the steam, and the steam pushes it around, which drives the magnet through the coils of wire to make electricity. Then there's this secondary cooling coil that takes the excess energy, absorbs it from the water so that the process can be repeated. And then over here, when we burn coal, we generate carbon dioxide and lots of other pollutants, nitrous oxide, sulfur dioxide, so some stuff that we don't want to go into the atmosphere. That's what this thing, this precipitator, it does. It catches those things, scrubs the air clean, so hopefully that we are producing less pollutants and producing less things that are going to go out and adversely affect the environment. Now, it doesn't matter, like I said, this could be coal, or we can use nuclear reactors. Just like there's nuclear radiation or nuclear decay in the core, we do that in a controlled way up in a nuclear power plant where radioactive material decays and changes a little bit of matter into a lot of energy, heats up water, and drives a turbine. If we're using hydrostatic power, then we build giant dams and we let water run over turbines. So instead of heating up water to make it move through the turbine, we let the gravity pull water over a turbine and do that. Or if we have wind turbines, instead of having water turn this, we use wind to turn it. So there's a bunch of different things that we do, but most of what we do is trying to take one form of energy, convert it into electricity so we can ship it all over our country and convert it into other forms. Now, the problem is not every form of energy is renewable. Some things are, some things aren't. So on a renewable energy resource, we can keep using that, obtaining it, and replenishing it. So if you think about hydrostatic power or hydroelectric plants where you have power plants built into dams, we don't actually as humans have to put any energy into that. We build this big dam and then we put a turbine here and the water flows through it and over it and we get electricity that comes out, and that's pretty cool for us. But what keeps this water up here? Well, the sun does that, right? The sun actually drives the water cycle, and so this river flows along down and goes out in the ocean, but water evaporates, clouds carry that around, it precipitates back down. So the water cycle, the sun, is actually powering this hydrostatic plant. The sun's not going away anytime soon. Water is pretty plentiful on the planet, so we're not too worried about this one running out. Wind turbine, same thing. The sun causes differential heating. We get wind patterns that develop to try to equalize pressure, and then we have wind turbines that capture the energy from the wind and convert it into electric energy for us. Those are renewable energy sources. We can keep using them over and over and over again. Okay, biofuels, this would be things like ethanol, because we can plant more corn, we can make biofuel from a lot of things other than corn. It's easily replenishable, we're not running out. Geothermal is when we actually tap directly into the Earth's energy from the core. We use usually steam vents or things near volcanic activity where we can use that heat to our advantage. Those are renewable sources because we're not running out of those. Those are easily and quickly replenished. These cause no pollution or less pollution than non-renewable sources. Now you're thinking, well, what if we're burning ethanol or these other biofuels? Isn't that causing pollution? Yes, but since we replenish it every year, right, the carbon dioxide that's released when we burn biofuel is then recaptured when we plant more and grow more of it. So it's a carbon neutral process to burn biomass. We're not adding any extra carbon dioxide to the air. Now, the drawbacks to this renewable energy source is it's expensive and there are some environmental impacts to it, right? If we go build a dam on a river, we're changing how that river flows, and we're changing how fish can migrate up and down the river, and we're changing entire ecosystems that depended on that river. So it's hard to build a hydroelectric plant and not change anything. Same with wind turbines; they can affect some things with birds and stuff. They're not so bad. But if you take and you build a giant solar panel array out in the middle of a desert, you're going to be messing a little bit with some of the ecosystems that are going on there. Now, there's non-renewable energy sources that are fairly cheap and easy to get to, but they also have some drawbacks. Okay, so we can't replace these easily. They take millions of years to replace, or we can't replace them at all. And the examples that we have are fossil fuels, which are coal, oil, gas, natural gas, and nuclear power, which is all basically based off this radioactive element, uranium. And we don't have another uranium source. Once we use that all up, once it's all been converted into a lower energy form, we're not going to get that back. Fossil fuels, technically we can get these back. The problem is the time scale. This is millions and millions and millions of years it takes for vegetation and organisms to actually go through the fossilization, the fuel process that stores this energy back as a fossil fuel. So we're consuming this much, 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 much faster than it can ever regenerate. And when we burn fossil fuels, we put a bunch of pollutants back into the air. So it's nice that these are easy to get to, and we've developed oil drilling and coal mining, and we can get to these, and it's pretty cheap. But we will run out. We are using it at a pretty incredible rate. It does cause air pollution. So when we burn fossil fuels, we're putting carbon dioxide in the air, we're putting some nitrogen and some sulfur and some other things in there. We create smog, we create acid rain, we create the greenhouse effect, we contribute to global temperature change. Now, nuclear radiation, nuclear power is actually very, 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 very clean. There is no smoke being produced. We're not burning anything. However, we do have radioactive material which can be very, very harmful and has to be stored until it decays into a low enough energy state that it's not harmful. The problem is we need it. We need pretty unstable stuff for our power plants so they have enough energy to generate enough heat to make the water into steam and drive the power plant. It runs out of that energy before it's done being radioactive. So it's still radioactive after it's no longer useful. So we have to store it for a while until it is no longer harmful. And transporting around radioactive decay is fairly hazardous, and it does present its own issues. Right? So what we've seen lately is we're trying to increase our dependence on these renewable fuels and decrease our dependence on the non-renewable energy sources.